Alright, now if you remember, we had talked about special systems when we talked about the graphing method. Now let's go ahead and see how we can solve the special systems by substitution. Now let's look at this example. We have 4x minus y equals negative 3 and y equals 4x plus 3. Now in this example, our second equation is already solved for y, so we can go ahead and take that and substitute it into our first equation here. So that will give us 4x minus, now since we are replacing this whole thing for y, you want to go ahead and put that in parentheses, equals negative 3. Now you have to be careful because you have this negative sign outside. When you remove these parentheses and bring these terms outside, that negative has to apply to everything inside the parentheses. So you will end up with 4x minus 4x minus 3 equals negative 3. 4x minus 4x will cancel out, and you're left with negative 3 equals negative 3. If I add 3 on both sides, you will see that I end up with, basically like if you were thinking about moving this over to the other side, you will end up with 0 equals 0. So in either case, we ended up with a true statement. Now, anytime you end up with a true statement of this form, it basically tells you that every solution of one equation is also a solution of the other. So if you remember when we did this graphically, we said when this happens, that means that the system has an infinite number of solutions. They're both the same line, they overlap, and your ordered pairs, all the ordered pairs corresponding to points that lie on the graph are solutions to your system here. So basically we will say this, your true result this true result means your system, means the system has an infinite number of solutions, and your solution set for this example is going to be, if you remember, we had used the set builder notation. So you have your ordered pair x, y, and then you can use any one of these two equations to use in your set builder notation, and we will go ahead and use 4x minus y equals negative 3. Okay, so anytime you end up with a true statement of this form, negative 3 equals negative 3 or 0 equals 0, we are saying that you have an infinite number of solutions. Let's look at another example here. And in this example, we are looking at the system 2x plus 10y equals 3 and x equals 1 minus 5y. Now in this example, you can see one of the equations right here is solved for x. You have x equals 1 minus 5y. So what we can do is take this second equation and substitute into our first one for x, and you will end up with 2 times, instead of x, we'll go ahead and put 1 minus 5y, then you have plus 10y equals 3. Again, you will notice this equation now is all in terms of the y variable. Let's go ahead and solve this. You end up with 2 minus 10y plus 10y equals 3. Your 10y's cancel out, negative and positive becomes 0, and you are left with 2 equals 3. And you can see in this case we did not end up with the true statement. You have a false statement. 2 cannot equal 3. That tells you that this false statement or this false result means that the equations are basically have graphs that are parallel lines, that means that this system is inconsistent and your solution set is an empty set, because if you remember, two parallel lines will never intersect, so you will never have any points in common, and that's why you have no solution to this sort of a system. So this means that the system is inconsistent and your solution set, if you remember, we had used this empty set or null set symbol, so that will be the solution for this system. So as you can see, when you have your special systems, when you solve your method by substitution, you will either end up with a true statement like we did in this example, okay, or you may end up with a false statement like we saw in the other one. And if you end up with a true statement, the two lines are the exact same line and you have infinite number of solutions. If you end up with a false statement, then it's an inconsistent system, the two lines are parallel and you have no solution.